Let's go to the picture. Please. Please, can you hear? I would like to introduce to all of you to the mayor of Villa de Cans.
The future mayor.
No.
You are very good friends. Okay, and all that we have now here in Villa de Cans, because he said to me one times many years ago, yes, no, this was very good, and he is a representative of the mayor of Ermua. Villa de Cans and Ermua, there are two different municipalities in Spain, and they are the share of one structure that is Impulso, connected with the ministry in Madrid, big country, and they are the group that will be the leader of Ciencia Acción for this year or for many years. I hope that. And then
Yo no soy su profesor. Te vengo a hacer la foto.
yeah. I like into the top. I don't know exactly who's. He's from Elmore municipality, and I don't know exactly what is the director. And she's from Villa de Cans. Yes, I said it very well. And you know, she's the secretary of this biggest structure that they said is connected. Is Impulso, okay? And Joan is a very important person for me. Because he is the person that when Jordi said yes, he was the person that had to do the yes.
He only said yes.
But the strong worker was Joan, okay? Then I would like to introduce very shortly the members that we have here. Pilar is from Argentina, is the Spanish team. We have Lily and Bat from Armenia, and Paula and Ambrose from Romania, Maria and Ivo from Bulgaria, Stefan from Germany, and well, I would invite. Imagine that I said the names because I don't remember. They are from Mongolia. She is Sologo, I remember very well. Is Bayat. And please, you are the best dressed in Europe. She is from Mongolia also. Okay. Then I would like to invite all of you to take a picture with us where the photographer say you are. Not here. No, well.
Mejor allí, en el frente de la mesa.
Muy bien.
Tenemos iluminación.
Muy bien.
Pues sí, en esa esquina.
Vale.
¿Y en la esquina?
No. Mira, yo me encontré aquí donde la tensión.
Sí, sí.
I would like to introduce Beatriz Garcia. She is Vice President of NASE, Network for Astronomy School Education. She is in Mendoza, Argentina, and she is the chair, the co-chair with me of this session, and she is invited to see our photo. Okay, all together. Ven aquí conmigo.
Abajo, alguno, porfa.
Young people, you,
Two more, please. Two more.
and you also, when you are very young.
Okay.
And correros más para acá. Okay. All of you, Lucas. Lucas is my becado. Ponte en primera fila, va. Sin Lucas no hacemos nada.
Venga, voy.
Venga, va.
Look at me, 5 seconds, please.
Cheese. Aquí se dice pata.
Okay.
Sí.
Muy bien.
I ara començarem a 2:00 puntual. ¿Dónde ponemos al que tiene que hablar? ¿Allí? ¿Stickers? ¿Te ponen la esquina donde el pone no? Es igual,
Bueno, pues yo creo que soy el estudiante que más veces han participado.
¿Tienes los powers nuestros
Yo solo tengo un power.
que te ha enviado Lucas, ¿no? Lucas,
No, el que me mandaste vos con el cronograma, es todo lo que tengo.
Vale, de acuerdo. Entonces casi mejor que pongas tú todos los powers. Lucas te envía ahora uno de los powers, el que tiene que salir a las 3 en puntos. ¿Vale?
Bueno.
Ya? ¿Vale?
Bueno, Rosa, yo
No, hay que quiero sentar yo. Sí. Vale. Entonces, el otro lo ponemos nosotros, ¿vale?
¿El otro cuál, Rosa?
De Cheese. Paula Cheese y Ambrose Cheese. El del análisis de los meteoritos. Está antes de las 3.
Bueno, me vas a tener que avisar porque acordate que puede que me
No
equivoque.
pasa nada, yo lo digo, tú ya me conoces. Aquí tú y yo somos informales, ¿no? Pues para adelante.
Bueno,
No pasa nada.
el de la presentación lo puse hace un ratito en el canal de YouTube porque ya estamos transmitiendo, ¿eh?
Vale, de acuerdo. Pues entonces, si te parece, ¿quieres decir 4 palabras tú o empiezo a decir 4 palabras yo?
Cuando desees podés arrancar porque está todo en marcha.
Vale, muy bien. ¿Se me oye?
Sí, sí, bastante bien.
Muy bien, perfecto. Well, momento de mirar mi churrero. Well, hello to everybody. We are here in Spain and Beatriz in Argentina. We are beginning the session online of this project about micrometeorites with NASE and UNESCO. You know that every year we organize one of these projects related to the the day of the International Day of Land. And in this occasion, we have the opportunity to meet here some countries in Vila de Cans. There are countries from Mongolia, Spain, of course, Germany, Bulgaria, Armenia, Romania. And also we have many participants in this project from 27 different countries in all the world. In particular, we received 170 reports from different countries, and in this moment there are also people that send the last reports that finished several days ago, but they are sending their final report and final presentation. Well, I would like to begin to mention that we are here in Vila de Cans because the municipality support us for this meeting. Of course, for us it is a very important situation, and we have the special occasion that to be here the representative of the municipality, Jordi Mothon, that he will talk a little bit because all the presentations, you know, that are very short in this kind of online meetings, about the role of the municipality in the development of science, and especially in science education. Because if we want to have future astronomers, we need to begin to introduce science strongly in the schools as soon as possible. Then, Jordi,
Thank you very much. Thank you. Thank you for coming here into Vila de Cans. As Rosa Maria commented, I am Jordi Mazón. I am a deputy major in science dissemination and science promotion in the city, among many other responsibilities like waste collection, mobility, and the pilot of the mission to become a neutral carbon city in 2030. So we are in the line to apply the science in many different issues in the city. And okay, as Maria said, Vila de Cans, one of the lines that are promoting during the last years and decades is to promote the science in the school, but also science in the open space, in the public space. So we have many projects where children's schools go to the open space, so the parks, the streets, to learn science. So currently we have now 4 projects that are very interesting. One of them is how to learn physics by using the parks, the toboggan, or all the pieces or the part in the park. All of them the schools can go there as another provision of the school to learn physics. We have also a project the mathematical route. So by using the streets, students in Vila de Cans can learn mathematics with moving and walking in several routes, mathematical routes. And also we have a street in Vila de Cans, in the city. The name of the street is the Sun Street, Carrera del Sol, the Sun Street. And there we have developed a project dealing astronomy, because by the name of the street, where students can download a project to answer questions, and the teacher explain things about astronomy and the sun, basically. So for us, for Vila de Cans, science is one of the most important things in education. And one of the proof that is important for Vila de Cans is that we are now in this space today. We are the site of Science Connection, where more than 100 students and professors and teachers from 34 parts of Spain are meeting here in the final, showing all the projects dealing science, and among these projects, many of astronomy. And also now in this time, in the same time than Science in Action, 27 students are debating, promoting, and implement, and how to implement the implementation of how to face the high island and the extreme temperatures in the city. This project is inside the Climathon. Climathon is a hackathon, but dealing climate. We are 8 cities in Spain and 38 in Europe. We are currently working to the implementation of how to solve the high extreme temperature in the city and the island in Vila de Cans. So science for us is a tool to solve the problems in the city, the climate problem, the climate change, but also to promote education in the city. But not only using schools, but also using the public space, parks, streets, etc. So thank you for the invitation to speak here with these few words. You will be always welcome to Vila de Cans. Vila de Cans is a science city, and in the coming year we have many projects to promote the science in the village, in this town. We are very close to Barcelona, 15 kilometers to the south. Barcelona, a small city, and we are motivated. We have a lot of engagement for promoting the science in the city. So you are welcome always in Vila de Cans. So thank you for coming, and thank you for this invitation for me.
Thank you, Jordi. We are very happy to stay here. And yesterday we have a very special edition of an activity of this year of micrometeorites in the different schools. And after we explain about it.
If you want the importance of science in Vila de Cans, 3 days ago, we were a delegation of Vila de Cans. We were to Tallinn in Estonia. And we defend a project to become a green leaf city in 2025. So Vila de Cans will be in 2025 a green capital in Europe to small cities lower than 100,000 inhabitants. So we get this challenge. So we will be the green capital in Europe in 2025, but to small cities, that is really. And the base of this project and the base of this the project that we are developing is based on science. So science and apply the science into the political items. We think that it's very important, and it's a very useful tool to be coherent with all the storytelling and to show all the things that we are performing in the city. So again, the science is very important, not only for knowledge, but also to developing political projects. So science is, you know, a key point in the methods of humans. In this case, in politics.
Yes, science is future. This is clear. Thank you.
Thank you. I'm sorry, but I need to leave because today here in Vila de Cans and in the building we have a lot of activities, and so I need to go down for.
Wait on. That's not one.
Thank you very much.
Thank you. We have here in the hands the final event of Science on the Stage Spain, and that is the Spain Ciencia en Acción. And then at this moment we have a fair with 100 different projects, and it is a very active the situation in this building in this moment. Okay, I suggest to Beatriz that maybe she want to introduce some words. I didn't invite you before because you know that Jordi have to escape very quick.
Yes, thank you, Rosa. Just to say hello, Good morning, good afternoon, everybody. And it's a pleasure for me to be here from Argentina, as you know, in the other part of the world. And I would like to give you the welcome to the activities in NASE, the annual activity connected with the International Day of Light, the UNESCO celebration for the light. And this year, I believe that the micrometeorites was a really challenging proposal, which involved a lot of people from different countries, cultures, ages. Was amazing, and we performed the activity in more places than the previous project. So we are very, very happy, and I occur a really productive workshop meeting this day. And well, please continue supporting the activities from NASE, which has as the objective to establish the bridges between cultures, and I am sure we are connecting people using the science, a cultural activity. So thank you very much. And if you want, Rosa, I can show the first part of the meeting. I don't know the timetable.
Yes, the next speaker, or the first speaker, is a primary school teacher in China. Geya Zhu, probably I pronounced very bad the name, sorry. But Geya is connected, do you know, Beatriz?
Which one, Rosa, sorry?
Geya Zhu is from the, I believe that probably they are connected from Beijing Planetarium.
Well, I don't know if she is connected. Hello.
Yes.
Hello.
Hi.
Okay. You need to share the screen. You have the permissions.
I would like to introduce her.
Okay.
She is the teacher at primary school. The name of the school is So 1, 2, Beijing, China. And the name of the presentation, or the title of the presentation is Searching for Micrometeorites with Students in this school that I pronounced very bad. And then, thank you, because I know that Geya was very motivated to visit us here in Vila de Cans. It wasn't possible for her, but in any case, I am absolutely very happy because they organize a very big, important team, and they promote that this activity will be carried out in China for many students. Yes, please.
Can you hear me okay?
Okay.
Yes.
Okay. Hello, everyone. I'm Geya Zhu from Zhongguancun No. 2 Primary School, Beijing, China. I'm honored to be here and sharing our experience in NASE Micrometeorites projects. As the title says, we built a team mainly with our primary school students to introduce the projects of searching micrometeorites following NASE guide to the public. It's a very interesting activity of great value for me and my students. First, please let me introduce our team members. The Vice Director of Beijing Planetarium, Dongmi Chen and Din Yang, give us very important information of how to run the projects. 6 of my students in our school astronomy club, Bohan, Yizhong, Yifei, Jingxi, Xueyuan, and Youchen are the core members of the team. Yizhong found a very good name, MOST, which means Micrometeorites Outdoor Searching Team for our team. We heard the news this June. Dongmi Chen told us that NASE was carrying out activities to searching for micrometeorites. Members of our astronomy club loved the idea of finding stardust in our surrounding. Then we quickly built a team and planned a series of activities, including group discussion, online meeting, live streaming on social media, and outdoor practice to promote the searching of micrometeorites. These activities attract more than 1,000 people to join, and several micrometeorite candidates were found and reported. Here, I want to reveal the timeline of our activity while sharing some of my thoughts to the project. The best thing here is that the project NASE providing is fun enough. Junior always loves space and wondering if there is any chance to get something from outer space. Meteorites are hard to find, but micrometeorites are everywhere. So they really want to find something in nearby neighborhood. And it's an easy to do project. NASE providing easy to follow menus. We can find magnets, plastic bags, paper cups easily. Identification in microscope is a little bit complicated, but we provide microscope identification for people. Submit possibly candidate photos taken by whole phone. The other tools are social media videos. We record some hand-by-hand videos to show how to make toys and search. And these easy-to-learn videos encourage people to join the activity. I'm also amazed to see my students learn a lot with fun with themselves in this project. During the process, we treat the project as something fun in life, but not a class to learn. We encourage core members to learn first and sharing what they learn in group discussion. So they have to make some localized menus. And these menus attract more juniors to join as they understand each other. The other thing is using school broadcasting. The presentation in school help us to quickly reach thousands of students to involve. And we provide links of easy-to-learn videos to whom might be interested. We also use social media tools to share information, such as online meeting, tutorial, and organize outdoor searching activities. Group work are always more interesting. Okay, let's go back to the timeline. In 13 to 28 June, core members collect lots of information from the website of NASE and a book named On the Trail of Stardust. Though the book is in English, some students try to use translation tools to get information from them and got the best ideas of what micrometeorites is. They also found some video and a presentation on how others do to searching micrometeorite. What they told me is that the beautiful image of micrometeorite in this book attract them to read by themselves. In the first meeting on 30 June, we sharing information in the group discussion and learn from each other. Every member have their own interest. Some love how to make toys. Some like how to stardust counts. And some providing standard forms to record the micrometeorites. This help each other to know what to collecting and how to find the micrometeorites. Then we use this information to make menus and guiding videos. Then we put a poster in our school. The students are very interested in the projects, and we got a chance to use the school TV to introduce it to all students in our school. members in our teams introduce the best ideas of the project. The beautiful image of the micrometeorites attracts lots of people. As the video here shows, our team members act as junior teachers and teach students how to make micrometeorite searching tools step by step. So the student can make their own searching tools and find possible candidates by themselves. We also provide links to easy-to-do videos in this broadcasting. And many students see these videos later when they get home and involved in later activities. During the summer vacation, our team used online streaming of our club's social media account. We provide step-by-step videos to show how to build collecting tools, how to search, clean, and identify the sample. And we also providing some gifts like bookmarks, club teddy bear for people answer the question correctly during our streaming. And the primary students just allow it. We also got many students in Longhu, Qinghai province, which is 2,000 kilometers from Beijing, to join our online streaming. As they are far from the big city, we hope they can find more micrometeorites. Now it's time to practice. Our team make various tools with material that is easy to get. Some follow the NASE guide, such as magnet with plastic bags or paper cups with a wire and magnet. Some of them also design their own tools. For example, micrometeorites trap with plastic wrap and plant in their outdoor carriers. They share their design on social media and use these DIY tools to search micrometeorites. We also make some outdoor searching together in the suburb and in school. We found particles are accumulated around the drains. This makes it a bit safer for us to conduct our search away from roof edge. We found a lot of magnet particles there. These particles are cleaned and identified in microscope. We have resolved hundreds of photos of possible micrometeorite photos. Of course, we have not yet finished all the identification, but we think the process itself are more important than the results. It also has some unexpected results. Some students make some food about micrometeorites, such as edible meteorite by chocolate and stick rice powder. Actually, it tastes very good. My favorite one is the impact craters simulated with flour, chocolate powder, and nuts. Its clear shows the structure of craters such as we see on the moon. Here are more videos and tutorial about the projects for someone who is interested to access. That's all. Thank you.
Thank you very much, Gabriel. It's an excellent project, and I was very, very impressed when you reminded me one of your videos in China. Of course, I didn't understand anything, but it was beautiful, very, very beautiful. And also, especially, I am really impressed because you involve 1,000 students. And this is fantastic. Congratulations. I don't know if somebody have any questions, any comments, maybe.
I just want to say that the project was amazing, very nice, and it's also surprising the young people involved, because the children were very, very young, and the idea to make the search all over the neighborhood is very nice, in different places with different samples, and I believe it's a good thing. I hope to upload all this material in NASE webpage.
Yes, we have all the reports that they sent to us, and of course we are happy, and we are in the moment to invite for next year continues working with us, and I hope to have the opportunity to meet and to can work together in some way, but face to face.
Yes, I also would like to give our thanks to Dong Chen, because
thank you, Elle.
hello, Donnie.
Yeah.
Because she maintained the activities in China, and it's a very important thing for us, because China is a country with a lot of inhabitants and with a great vision about science and citizen science. So thank you very much, Tony.
And I would like to insist that they are working with us for many, many years. And this is very positive, because 1 year is not enough. The continuity is the much more important in this kind of projects. Thank you very much to China, and see you again, and to continue working with us. I would like to introduce the next speaker. The next speaker is Fatima. Fatima was here a few minutes ago. I remember to see her. Fatima is from Iran. Iran is a very, very active country in NASE also. And I don't know if we lost the connection with Fatima, maybe, you know? That is.
No, I cannot see him or she. No, yes, her.
Is a woman.
Yeah. I cannot see her, but if you want, we.
At the beginning, I saw her. It was in.
Yeah.
Well, doesn't
Yes.
matter.
I know.
That we continue, and the next speaker are here. They are Ambrose and Paula Cheese from Romania. They are from George Panitiu School, and the title is City Stardust: Comparison between two micrometeorites. I suggest that they sit here, because both of you, okay, it's up there, the PowerPoint. No problem. Okay. But it doesn't matter. You are in front of the camera, I should rest. Thank you, Rosa. Numbers. Fatima is here. Okay. Irma, sorry, Beatriz, Fatima is there. What about use with Fatima? And because I know that the connection with Iran is not easy. I suggest.
Yes.
Fatima, is possible? Yes.
Hi. I need just one moment. I have some internet connection problem. Less than 1 minute, I will be ready for presentation.
Say something in between She tried to find the PowerPoint. Iran is an important country in NASE also. They are working with us for many years, maybe 10 or something like that. And I would like to recognize a special work organized by FATA. I received 80 reports from Iran, but not from the same city, for many different cities, for students very younger, for older students, also some in the university, some of them secondary, primary school. Is a very important big mixture of different people from different age and different quality of work, of course, but they are excellent work, very well prepared. With also, it looks that they have a special country that like is an umbrella for micrometeorites because they receive many of them. If Fatima is reading, we can begin. Did you find the PowerPoint?
No, unfortunately, something's happening here. I have to change my laptop. Everything's. Just let me 1 minute.
Okay, I will talk a little bit about Iran. Well, I would like to mention that in Iran they have a strong organization of astronomy teachers that they work in all the country, and they are also involved in all the our courses, our projects, but also they organize many courses of astronomy, astrophysics, astrobiology, and in particular, they have one special constructor. There are the Chattakis, and Chattakis are very special. It's very connected with astronomy, and the orientation is very special. And well, in the past, the Persian was in a special situation with the Roman Empire. They have different wars. And the Roman that copy from all the places where they discover something interesting, they copy Chattakis, and there are Chattakis in all the Roman Empire. There are in Spain, there are in Vienna, there are in Rome. In Rome, there is one of them very important. And there is very special, the culture, and very connected with astronomy. Then I think it is a wonderful lucky for us that Iran will be so important in the work of astronomy, and they work very well at secondary and primary school. Well, I finished my speech. No? Yeah.
Yeah. Yes. I believe she's here.
Fatima, when you want.
You are mute.
Okay, hello everyone. I'm sorry for this. Some internet connection. We have a problem for internet connection right now. Okay. Okay, everything is okay.
Yes, perfect.
Okay, thank you very much. Ladies and gentlemen, good afternoon. I hope you are all doing well. My name is Fatima Hashem-Nassab. I am the Vice President of ITAU, Iranian Teacher Astronomy Union, and I'm delighted to stand before you today to share the remarkable and exceptional work that we have undertaken here in Iran. And I will explain our experience through Micrometeorite project. And as you know, today our meeting is not just about passing information, it's a celebration of discovery and learning. And I want to tell thank you, Nasser, thank you, Rosa, for fascinating project. This project provides an excellent opportunity for our teacher to bring the cosmos, the astronomy, closer to their classrooms, and by using that, inspire and educate their students. And in fact, this project made it possible for our students to teach, to touch, and reach out cosmos themselves. And fortunately, through this project, we have near 200 students from different parts of Iran. And I will explain you how we manage and organize this project in Iran. Okay, but let me, I provide some additional background information, how we start, what's happened before this project. In Iran, the new year we call Nowruz. It exactly start with the commence of spring, precisely during the March equinox. We call this Nowruz, and every people gather together and celebrate this special ceremony. And in our astronomy community, Saqib astronomy community, we celebrate the arrival of spring in the 3rd of Nowruz. And in this year, in our New Year meeting, we had honor to awarding NASE certificate to our students who dedicate their time and their effort to previous NASE project. And as you can see, their photo, they had received their certificate. And in this meeting, we received one special video clips from Rosa, and Rosa in her video clips share with us a micrometeorite project. And after some weeks, we received this project and we found this project interesting. Due to some ongoing projects, it was at the 1st of July, we have found the time to start this project in Iran. So we have just 3 months to do everything, to do a huge job, huge work in Iran. And I will explain you how in 3 months we could organize this project in Iran. Our management has had 3 main key steps. The first was preparation. The second is project launch and information dissemination. And the last part of this, collecting data. I will explain all of them step by step. The first step was preparation. And without a doubt, it was important because it's required precise planning and foresight. In this stuff, we dedicate our efforts to prepare everything our teacher or our mentors might need, and we carefully consider every possible requirement. And in this step, we try to provide everything, and it was include translation NASE material into Persian, provide informative video clips, establish a support advisor groups, and provide FAQ and guidance for our teacher. As you know, the first step and foremost endeavor was the translation NASE material into Persian. Our primary language in Iran is Persian. So we recognize the importance of making project material available in our native language. And we start translation all NASE material in Persian. And this translation helps us to bridge the language gap and enable more individuals to engage in this project. As you can see here, here is original of NASE material, and here is Persian version of this material. But we didn't stop at translation phase. We knew that some of our teachers may not be familiar with the subject, with the micrometeorite. To address this, we created informative video clips, and these video clips as valuable educational tools and guiding our teacher how to do this project. More than this, we prepare guidelines, information, and we prepare FAQ list about this project. And to bring all these resources, we put all this material in our website. And this website became the hub of our project, and everything was in this website. Moreover, we organized some face-to-face meeting about micrometeorite. And during this gathering, we share in-depth knowledge about the
I think it looks like.
There is some problem. Can you hear me?
Yes, yes, yes. But
She touched some key, I believe. I see a but now she cannot answer me. Hello, hello. Well, perhaps, yes, was a problem. I don't know. It's a connection problem, I believe.
Maybe we wait some minutes, some seconds.
Yes, Fatem is here again. I don't know. Hello, Fatem. Okay, she is here again. Hello, what's happened?
I'm sorry, Rosa. No, we have a many internet connection problem in Iran. I'm sorry for
Okay,
this.
I believe you touch a key because I received a message of recording in progress or something like that. Take care with the keys in the share screen.
Okay, maybe. I'm sorry.
No, it's okay. It's okay. Let's start again.
I will continue my speech.
Yes.
Okay, let me. Okay, okay. Okay.
Okay. Hello. Rosa, are you there?
Yes, I am here.
Okay. Yes, no, just in case that the problem was me.
The problem is Iran, I think. But it is not so strange. I have many courses with them and they have
this kind of situation. Yes, internet is not stable. Okay.
It's not easy. Okay. Well.
Okay. She's trying again. Okay.
I suggest that it is possible for her. Finally.
Well, the alternative is to have the PowerPoint.
I'm finished, yeah.
No, she's not here right now. Okay. But I can see how the people enter and go out in the same region. So evidently it's a connection problem.
No, be sure. Well, we wait some seconds more, and after I suggest to continue with the next one speaker.
Yes, and complete the presentation is not the best, but to complete the presentation in a few minutes after the next speaker, if you agree.
Yeah. The next speaker, they are ready? Yes, close to me.
Because I am there, yes. The best is a presential way, yes, evidently. We need to come back to the presentiality, yes. Okay.
Well, maybe we begin with the next one, okay?
Yes,
okay.
I agree. Okay.
We put the PowerPoint. Well, I would like to introduce Ambrose and Paula Cheese from Romania, and they obtained
the window on the right.
the window, small.
Minimize this one, yes.
That one, please.
Thank you.
Okay. Then they are working in Romania, Cluj-Napoca, and they have the opportunity to obtain several micrometeorites, and they work one step more, not only to have the candidates of micrometeorite, that they continue working with them. Okay, please explain this.
Hello, everybody. My name is Paula Milic. I am a physics teacher in Cluj-Napoca, Romania.
And I'm Rosie Kish, also a physics teacher in the high school in Romania, Cluj-Napoca.
In our country, during a school year, we have a special week when we have to study with the students something different from the curriculum. We have to make some projects and different and interesting activities for them. So it was a very good opportunity for us, Rosa, to have your project with micrometeorites. So we worked. I worked with 6th, 7th, 10th, and 11th graders. So gymnasium and high school students. And we did the experiment to find the possible and candidate for micrometeorites, which is a very, very important and precious label, this kind of micrometeorites. So we are looking for them. And we start and we will continue this project. We will not stop here. And now we want to show you some of our work, our teamwork, because we are a team. And next slide. Yes. You have to put the window down because we have something right and the big one. Yes, please. Yes, and the other one. Put it down or close. You can put it on the.
Okay.
Perfect.
Without.
Here you can see some photos. We did this hunting for micrometeorites in our schoolyard. And here are the pictures we've made. Here you can see on the cup, on the plastic cup, some of them. We found it in the gutters. There you can see that picture. Next slide, please. As you see here, we have pictures made by our students, and we make them bigger just to maximize the effect, because they are so small, micro, that means the 1,000th part of the millimeter, of course. So this cosmic dust, it's formed in these droplets during their hypervelocity entry into the Earth's atmosphere. And of course, at the end, spread out all over our planet. What we are looking for? We are looking for the spherical shape, but first, the property to be ferromagnetic. They are attracted by magnets, as you know. Next slide, please. Here we have other types, other pictures, other possible micrometeorites found by our students. And the one of the right is very special. Here is another one. We did these pictures in the university with some help, of course, with very special optical microscope. But you can see here on the left side of the sphere, and on the picture of the right, other side of the same micrometer.
The next step was to use a scanning electron microscope which is an analytical tool used in science in collaboration with an institute of analyzing instruments in Cluj. And we use type of Tescam Vega electron microscope, which also has an analyzer which uses X-ray spectroscopy to find the composition of the parts of micrometeorites. And we have the results of two micrometeorites here. Also, you can see the magnification and the scale, and also the voltage that we used there. It were scanning photos in electronic microscopy, which we take and try to find if they are truly from outer space. I mean, they have the composition right. And we have some results here, composition of the first with usually known elements in iron, oxygen, titan, silicium, calcium, and so on. And also, we had an interesting map of the distribution of the elements that we have studied with different colors and concentration. And the same, we have the second, like I've said, micrometeorite with a little bit difference in composition, which was interesting here that we find, they find, I mean, a little portion of nickel, which is from some literature observation, it's a key point sometimes to establish the nature of extraterrestrial origin. Continue.
And the size of this one is clearly smaller than the other one. The other one, we were talking about the size, and we were upset because it was too big. And we think this is not too big, this is the properly size. But then we found another scientific article where they said, it doesn't matter, we can say giant micrometeorites. So we don't know yet, we will continue to study the problem.
The problem here, as we read some scientific articles, is there is not a clear standard classification and rules for this is or this is not. And this was our travel to compare, to see is that, is not. And this is
it's a new field for us. But what you see here, this barrel, olivine maybe, I like to believe it is a barrel olivine. It's because of these shapes here, the lines, and what you can see here, the charge like a.
The majority of the people don't see you.
Okay.
Because the camera is there.
But we don't know. We don't have see.
No, but I want to say when you put your finger and this
They don't. On the black picture on the bottom, you can see an image very close to the surface. This one, yes, they don't. Next slide. And we were looking for a chart to know the composition of the micrometeorite, a possible chart, and we found this one. Here you have for iron, the concentration. Here are a lot possible micrometeorites. And silicium and magnesium, very rare. But
Okay.
still, here they might be.
This can be a criteria to be in this kind of the compositioning of these three, I mean, elements in the that's we did. Okay, okay, and after like I've started studying some scientific literature about this type of cosmic dust, we think that using one of the most cited authors, Gang, and we have the article in our bibliography. He established at least three essential features having magnetite shell, bearing nickel and iron, and chondritic composition. We think that we have at least two of these characteristics, and we think that we find this.
If you see here, chondrites has in their composition iron, magnesium, silicon, and oxygen, and we had that. In the second one.
Okay, but you can see also here a little. We use another electron microscope from Papeete University, and with the help of our friends, of course, we find and try to see composition in this. For these particles, spherules in different portion, interesting portion of the micrometeoric burst. You can see that it's only a portion here, and the composition and the mapping of the distribution of the elements in that region, like you say.
Here are the elements, and each color means another element.
The distribution of the element here. And
they said maybe if we touch with our finger, it is compromised for this kind of precisely.
This is here another portion of another micrometeorite, which is very interesting because it has a lot portion of titanium, and you can see also in the distribution of the element here is maybe. And with at least we think this also is and the other one, the third, it's about
this kind of characteristic like a crater
on the surface.
I read something on the surface. I read something. It's about it's a characteristic for micrometeorite.
And you can see the big image, the composition, and the distribution of the elements on that spot of that spot of them. So,
go on.
Conclusion.
The students were and still are very interested in finding micrometeorites. So we decided to continue for us to learn, for them and using scientific methods also. Interesting for high school, they know about electronic microscope, they know about spectroscope, they know about all that, so they can understand where to use those kind of important and difficult tools, science tools. They learn about more about the different layers of the Earth atmosphere. The little one from the gymnasium, we used to say like story, the trip of a micrometeorite during the layers of the atmosphere, what happened with it, what speed it has, what density meet during the travel. The temperature, very important, the temperature of the layers from this trip during enter the atmosphere. So we propose to them to make a collection and maybe even a photo album with what they find.
Also the scientists that we have help for using the instruments that you see are so interesting. They were heard for the first time. Where did you find that? What is that? And maybe this is the beginning of a beautiful friendship, like a famous quote. And maybe we will try to find, because they are, it's like, maybe many of you, the searching for the urban meteorites begin only maybe not 10 years, 7 years, because it was a myth. You cannot find this kind of rocks in the city. But it seems that we can, and maybe it's a good start on a beautiful continuing project in our condition. And here you have, of course, the bibliography that we, at least we use.
More than that.
Okay, and the last one.
But this is the extra domestic area.
Yeah.
First of all, I know. Well, I hope that I don't see, yes, I don't see because here, Beatriz, Sultan,
I am here.
is there.
But I don't know if our friend from Iran wants to
Yes.
finish the talk.
Yeah, I'm sorry, Rosa. No, we have a many internet connection problem in Iran. I'm
No,
so
it's okay.
sorry. Can I continue?
The next one, and if you want to finish briefly your presentation.
Yeah.
Yes, Ivana, if you let me, I will share. Okay. Okay. As I told you, we have advisor groups. After each student group and their teacher enrolled in this project, we allocated one advisor for each group, and they remained with their groups entirely in this project and help them answering their question and addressing any problem that arose. And after we prepare everything, the time arrived for launch the project in the country. And two main institutes help us in this step. One of them was Saqib Astronomy Association, and another is Institute for the Intellectual Development of Children and Young Adults. We call this Kanun in Iran. Saqib Astronomy Association is one of the old and one of the most active amateur astronomy groups in Iran. They help us and they announce the project in its website and in their website, in social media, same as Instagram, WhatsApp, or more than this, they send letter to schools. And we try to spread the project with Institute for the Intellectual Development of Children. This institute has vast branches in each city of Iran and has a wide networks, and this network help us to spread the project in all different parts of Iran, and they send letter and project material to their branches in various parts of Iran. And thanks both of them, Saqib Astronomy Association and Kanun, and the collaboration between Saqib and this institute brought together students and educators from various cities of Iran and remote area and village from every part of Iran. And the last step was collection data and send them to NASE. It was the 1st of August, and until to September, we had the time to spread this project in Iran. Unfortunately, at the end of September, we had nearly 205 students has participated in this project with the support of 38 teachers and from 9 provinces of Iran. Iran is located in the Middle East and is a huge country. If I have a time, I prepare a video clip and I can show you student works and their micrometeorite. Do I have a time or not?
Yes, try.
Okay. Okay, thank you. Okay. Okay, can you see or not?
No,
No?
we can hear, but not see.
Okay, let me.
Yes, I can see.
Oh, yeah? Okay.
I can see it. Yeah.
Oh, yes, now, yes. Yes,
Okay.
perfect.
This is Gilan. This city, this province is in the north of Iran. Near 58 students has participated from this province. We have 4 main centers participated in this project with near 10 teachers. Some of our teachers organize face-to-face meetings. Some of them organize online meetings, and they try to find micrometeoroids from everywhere they can, from gardens, from near their centers, and they try to use microscope to find more micrometeoroids. And this province where our Saqib Astronomy Association is there. And so most of our students from this province, and they try to determine the size of their micrometeorites. Another province is Mazandaran. We had here Mr. Fathi. He tried with near 10 students to participate in this project, and they try to find their micrometeorites. And you can see their amazing pictures, and they were very enthusiastic to this project. Some of their young, some of their old, from elementary school to higher school. We have a wide range of students. Another, and you can see here, our students try to find everywhere in their yards or in the streets. Another city is Tehran. Tehran is the capital of Iran. From this city, we have science centers that participate in this project. Near 16 students, near 8 students participate in this project. This center has a good instrument, and another is home. From this project, yes, we had near 32 students participated in this project from 1 centers, and they try to find and classify their micrometeoroids, as you can see in this picture, and they use microscope to find more and more micrometeoroids. And you can see here their classification. Another province is Kurdistan. They did the best, and they provide a good collection of micrometeorite. Their teacher was Mr. Bahmani, and they try to determine the size, classify, and as you can see here in this photo. Another is Kermanshah. Kermanshah is located in the west of Iran. And from this city, we had near 16 students from 4 centers, and they try to find their micrometeorite near their centers, and they have a face-to-face meetings. Some of them provide interesting video clips, and they send to us. Another is Fars. From this province, we had near 36 students. We have an amazing teacher in this city, and their city is named Pasargad, the astronomy city of Iran. We have a wonderful teacher. His name is Mr. Kariri, and he dedicated all his life to astronomy. And another city is Khuzestan. We had 9 students from 4 provinces. And finally, we had a Bushehr in the south of Iran. And from this province, we have 30 students. This is my province, and I went to some village, some remote village, and with a student, we try to find micrometeorite. Thank you for your attention, and I'm so sorry for my internet problems.
No, not at all. Thank you for your great presentation. It was very, very nice.
Thank you too.
Was very impressive work for all the country. Thank you very much.
Thank you too. Thank you, all of you.
Thank you. Well, Rosa, we can follow with the next speaker, right?
Right.
Yes, I have the the pleasure to present Nicolás Vázquez. I would like to show the second page of our timeline. Is here. Well, Nicolás is a professor at the Escuela Politécnica Nacional in Quito, Ecuador, here in America. And he will talk about micrometeorites from the middle of the world in Latin America. Nico, are you there?
Yes, good morning, everybody. It's a pleasure to be here with you. And I will share the screen. Wait
I
for
believe
a
you
minute.
can. Yeah.
It's
perfect.
okay. It's working. Well, as Beatriz said, thank you for the invitation, Rosa and Beatriz and everybody. We also did the project from NASE in America. And I will talk from Ecuador since we are in the middle of the world. And it's maybe quite interesting because in Ecuador we have not only many volcanoes, but also some special conditions that we can have some paramagnetic sands. As you can see here, maybe, are you looking my glass? Then it would be more difficult to find micrometeorites because we have some sands that have already these ferromagnetic materials, and also volcanoes, when they erupt, they also expel many ferromagnetic materials. Then you have to be careful when we are looking for micrometeorites in Ecuador. As you can see, it's interesting in Latin America. Our language is Spanish, except Brazil. Everybody speaks Spanish and we can communicate easily. And I'm from Quito. First, I would like to introduce some emblematic meteorites that fall in America. We have first Chicxulub, is the one, the biggest one that has the consequence of the extinction of dinosaurs. It falls in Yucatan Peninsula, as you can see here. And not too many years ago, they finally established that that was the more probable cause for the extinction of dinosaurs. Also, it's interesting that in Argentina, we have the biggest meteorite park, Campo del Cielo, in Chaco province, where you can find really huge meteorites that falls in this province of Argentina, and it's touristic attraction for people who want to visit this kind of rocks falling from the sky. Well, as Rosa and Beatriz propose, we joined the activity of the Day of Lights. The main idea was to bring science to schools and teachers and say that science is funny and you can learn many things. And also we participate in this 3-step collection. We find first some place where material can be collected near streets. With the magnets, we separate and we look for meteorites. Important to learn, students and teachers, that you need to report your experiments to be compared with other sites where they were performed. And it's interesting because we can share these activities. And since we all speak Spanish, it's really easy to talk between us. In Ecuador, in Latin America, we did 25 experiments. In schools, teachers and students were involved, not only from high schools and university. And the countries that participates were Paraguay, Argentina, Nicaragua, Ecuador, Colombia, República Dominicana. You can see some pictures. That's what is in Quito, in my university. In Ecuador, we worked with the Ministry of Education, and the idea is to have this contact between university and high schools to make this process of changing from secondary school to university more easily with strong bases, especially in science. Last NASE course was done 2 weeks ago in my university. We have more than 40 professors. Beatriz, we have the opportunity to bring Beatriz on site from Argentina, and that was a really nice experience. And also I can show some other pictures from Colombia and from Nicaragua, where you can see that the diversity of people, and we're really happy to have this kind of approach of science to our community. We're very thankful to these institutions that can support this project, and especially thanks from Rosa and Beatriz to invite us to participate in these interesting projects. I think that's a small resume of what we did in Latin America and Ecuador in this project.
Okay, thank you. Thank you, Nico. The people in Spain, I mute you because some noise, but I cannot unmute. So please take, okay, thank you. Thank you, Nico.
I always say to Nico that it was very happy to see him. Encantada de verte, sigue tan guapo como siempre. Venga.
Muchas gracias, Rosa. Qué gusto también saludarte a los tiempos.
Okay, thank you.
Okay, I think we can follow. I don't know if Kyuhu Sud, I think is the name, is here. Because the next speaker is Kyuhu Sud. And the talk is about observations of ablating micrometeoroids using high power and large aperture radars. Are you there? Rosa?
I don't know.
Can you identify him?
Yesterday and say to me that will be here. Yesterday, see if I can make him.
Okay.
He said, I am waiting for the Earth to start the meeting. Maybe it's in the other Zoom. Do you remember?
Well, I don't know. You sent the message.
You have one email.
Well, I will try them. Well, okay, the next one is the summary. I don't know if you want to.
We begin the summary. You contact with him. Okay.
Yes. Yes.
Excellent. Then I would like to suggest that Paula and Andros change the position and to invite to the speakers. You to sit here. Yes. Ivo also stay put here, close to here. You are always, nobody see you if you are there. Yes. Yeah. No, with QM.
No, from the
PowerPoint. Beatriz, where are you?
Yes, I'm here. Tell me. Okay, but I cannot do the two things at the same time with the same computer. So if I manage the PowerPoint, I need some time to send the message to.
We can put the PowerPoint ourselves.
Okay.
We put PowerPoint and you contact with
yes.
From Miami, okay?
Thank you.
I have my 4 speakers here. Yeah, this one. Yeah. I prefer to introduce at the beginning them. I begin from that. On the for you on the right, Stefan from Germany, Stefan Müller Chambrinon.
That's it.
Well, the second is from Mongolia, but I am cool.
Yeah.
She's, you say your name. Okay. And after, he's from Mongolia, Ivo Jokin from Bulgaria, and give your name. Bakarchan from Armenia. Okay. Then the first speaker will be from Mongolia, no? No.
Yes.
Ivo, now, I am very happy that you decide who is the best.
The first.
This one.
Yes.
Hello, hello everybody. My name is Jokin. I'm director of the Municipal Center for Extracurricular Activities and NASE coordinator for Bulgaria and coordinator for International Day of Light of Bulgaria. We are very happy to participate. Thank you, Rosa, NASE, this chance. So we're promoting the project, looking for micrometeorites during our national Astro Party. This is the national activity, more than 20 years under Ministry of Science Education. We bring more than 20 teachers and 60 students from all country. So in 2023, we are promoting this project. Next slide. We're organizing several workshops during a party when my students from Astro Group produce this complex set, very easy with everyday materials, cup, magnet, and we produce more than maybe 100 from this to give teachers and students. And start to searching micrometeorites, also creating creators. How we translate with my students into Bulgarian language, and I prepare this book for each students and each teacher to be useful when they working. Next slide. And here is a very new, from yesterday, this picture. It's very nice students here in the local school in Villa de Cans, 5 group, maybe more than 150. And we're organizing this activity. We give them a cup and magnets, and they start to searching my micrometeorites from all your school. We was very happy. We fixed candidates of micrometeorites with scotch, and they write his name and dates. Also workshop with make craters. So with amazing day, thank you for a local director of this local schools, Sales, Institute Sales, and teachers. Thank you very much for your attention.
Hola, that is the first word which I learned in Spain. My name is Bartli. I am from Armenia, and I want to say that this program we also did in our country, in another school. And I forget to say that I work at European Observatory, and I work at school number 125. And we did this program in our school and other school. And I want to say that after that program, children start interest the astronomy, the physics, and science. And I decide to improve that and did this program. Please change. did this program another school. Now you can see the picture when that is our school. I help our children to do this work. And the next picture, please, next slide. And the next slide, you can see the our children. There are see the result. And I think that when we are continuing this work, we can children can more interested in the science. And thank you very much for attention.
Hello everyone, my name is Bayer from Bulgaria. I am an educator of Extreme Education Center. Next. And first, I would like to say thank you for organizing this kind of wonderful to Rosa and her team. And we did this project on hobby private student national project, National University of Mongolia. And around 15 to 16 students attended. Next. And this whole picture was yesterday's pictures. And we went there, Olympia High School and Mariman High School. And maybe seven groups attended this experiment. It was a wonderful experience for us. Next. Thank you for your attention.
Thank you. Thank you, Ola. My name is Stefan Müller. I'm from Germany. And thanks, Rosa, for this wonderful experience here. Rosa told me to introduce you to some ideas that I had of improving the collection and getting the micrometeorites out of the material. I tried that back in Germany with students, and I tried it yesterday together with Riccardo Romano, and it was successful. So Rosa asked me to show some things that look funny, but are fun and that do work. For getting more material, everybody knows this. For getting much material from the streets, just collect huge piles of material with that. Looks fine, it's fun, works. And then take some plastic bag with a magnet. So you get lots of material attached here. That's a good way to get much material. Easier way, even if you don't have something like that. Just get some paper, fold it like that, put a magnet inside. You can retrieve much material from there. That's easier than with that cup. That's what we figured out. I've been out in Germany. We figured out yesterday as we were invited teachers at the school. And the last thing, looking funny, is a gold washing pan. Some people might know from Western cowboy movies, but it does work because put water in, put the material in, wait for heavy, denser material to settle, and then shake the water out with these stair things. You can select denser material, and that's a way not only to get magnetic matter out of what you collected, but even stuff that's not magnetic and could be micrometeorites, not being made out of iron, not being made out of nickel. You can find them with that. And I think Rosa asked me to put that into the book as well. Maybe I'll write more about that there. One final thing we figured out with the cups, don't use cups like that, use cups that are closer to the ground. but that's probably an experience everybody had who's done that before. I've got some more ideas, but don't let me put too much here. It was great fun. Thanks for having the opportunity. It was good time at Carlo Romano, good time with the students at school, good time with all the invited teachers here. Thanks a lot, Stefan.
Yes, it's true. As you know, we prepare in every year one small booklet about to collect all the experience after this event, local experience in the face-to-face meeting, and also the experience in the online edition. Then, of course, we will prepare this material. I will ask to all of you and send me some small contribution, very small, because you know it's a booklet, and also many photos, because if we want that the book arrive to the students, it should be very attractive. It looks that you need to open, because it is beautiful, and this is the idea that I will continue working. We don't finish here, we continue. But in any case, I think that this is a wonderful collection, mosaic of different contributions that I hope that motivate more and more the people in order to continue with this activity, because it's not necessary to stop now. Well, we have connected with our speaker from Miami.
Yes, I believe so. Now, yes, I would like to introduce Kihu Su. I hope pronounce well the name, from Miami University in USA. And the title of the talk is Observation of Ablating Micrometeoroids Using High Power and Large Aperture Radars. Professor Su, are you there?
Yes, I'm here. Okay, thank you very much, for the introduction and for the invitation. Good morning, buona tarde, and 晚上好. I'm sorry, I had a little bit difficult getting in, and my talk is a little bit different, I guess, from the rest of you, what you have talked about. My talk is more about meteoroids instead of meteorites. So I have a slide prepared, so I'm going to share my slide with you. Bear with me for a moment. Let me share the slide.
Yes, you have all the permission.
All right, let me see if actually I can do the slideshow. I haven't done this for a while. Okay, can you see my slide?
Yes, perfectly.
Okay, all right. So as I mentioned, that my topic is more about micrometeoroid observation using the world's high power and large aperture radars. So I'm from Miami University. So here's a brief outline of my talk. First, I will briefly introduce what radar meteor echoes are and how do they look, and then we'll move on to meteor observations made at Arecibo. I will talk about the observational characteristics and the meteoroid velocities and the mass, and as well as radiant studies, and then I will come to the conclusions. I think it's cutting off on my side. Okay, the slide does not seem to be complete, but probably it's okay. So the top line reads meteoroids, meteors, and meteorites. So I guess we come from a different background. I just want to clarify a few terminology. Meteoroids, these are the dust particles roaming the solar system. Meteoroids are subject to all the forces that planets experience, and plus that because they are small and they may be subject to radiation and the solar wind, radiation pressure and the solar wind drags as well. Meteors are those ablating meteoroids. And this is what we see. They typically are characterized by a big trio visible with the visible light. But for what I do is I look at the signature of ionization. I don't look at the light. Okay. And of course, meteoroids, that is what you are interested in. And these are the surviving meteoroids reaching to the surface of the Earth. So the radar meteor echoes, they were observed as soon as radar was invented in the 1930s. But the first organized meteor observations was not done until the 1946. So on this top, you can see my cursor, right? Can you see my cursor?
Yes.
Yes,
Okay.
yes.
Okay, all right. So this is sort of the early photograph of a meteor echo. So a meteor echo is just if you observe this is a time and this is a height or range, the distance. And so if early meteor echoes, most of them show as a straight line along the time. What that means is it is fixed at a certain range and lasts for a certain period of time. So if you look at the echo power, most of the time that it shows exponential decay. And of course, now we have observed more meteor echoes. Mainly there are three kinds of meteor echoes. The first one is a trail echo. That is traditional observed by meteor radars. And those meteor echoes, they come in the direction perpendicular to the pointing direction. And these are mainly observed by very high frequency radar, medium frequency radar, and then you don't need a whole lot of power to see those kind of meteor trail echoes. A very small radar would allow you actually to see those type of echoes. And then there is the so-called range spread trail echoes. Those echoes, they are observed when the radar direction is pointing perpendicular to the magnetic field line. So this is an example of meteor spread trail echo. These are observed by more powerful VHF radars. Some VHF radars, its typical frequency is from 30 megahertz to about 300 megahertz. And then there is this other type of echo that's called a height echo. And that is shown here. It's a slant line. This is time and this is the range. Of course, what this shows is the meteor is coming down at the radar. Okay, because at the beginning is from a far distance and to a lower distance. And if you look at the slope, that is correspond to the speed of the meteor. So those head echoes, they are sort of, they accompany the meteoroid. Okay, they are the so-called overdense echoes. That is, the plasma density exceeds the radar probing frequency. And those echoes are typically observed by very powerful UHF radar, which that frequency is about 300 megahertz, as well as VHF radars. And so this is sort of a few radars that I'm showing here. Even though meteor echoes have been observed, for a long time, but very large aperture high power radars were not actually used to study meteors until the 1990s. In the 1990s, the three radars at three facilities, they were sort of simultaneously used and independently used to study meteors. One radar is Arecibo. Arecibo operates at 430 megahertz. Arecibo is located in Puerto Rico, and of course, some of you might know it collapsed 3 years ago. And and there's a Hicamaca radar that's 50 megahertz. A Hicamaca radar, since it operates at a lower frequency, it doesn't need a dish, so it just is a large dipole field. And there's also the European in-current scatter radar. There's a tristatic radar, and one of them operates at 24 megahertz, another is at 930 megahertz. So those are, those three studies initiated the sort of the era of using high power large aperture radars to study meteor echoes. And those high power large aperture echoes, they're predominantly head echoes that is shown here. So my focus is more on the Arecibo radar. So here is the Arecibo radar, and this diameter is 305 meters, and its transmitted power for 2 megawatts. It operates, as I mentioned, at a frequency of 430 megahertz. The radar is very powerful. It was the most powerful radar that we have ever built, and just how powerful it is. Well, if the observable effective cross section at 100 kilometers is 10 to negative 11 square meters. So what that says is, if you put a pinpoint, in theory, you should be able to see it. Of course, because of Rayleigh scattering, and then if you have a pinpoint, the effective area is much larger than 10 to 11 10 to negative 11 square meters. But of course, because of Rayleigh scattering, and then there is a reduction about the power if you just actually put a pinpoint. So with the Rayleigh scattering taking into consideration, the Arecibo radar actually can easily see a penny at 100 kilometers away. So the meteor echoes, however, at Arecibo was not reported until 1995, even though the radar was powerful. Yeah, part of the reason was that they only last a few milliseconds within the radar beam. So they last for a very, very short period of time. And of course, before 1990s, and there was the data taking technology was not there. You cannot, resolve the time resolution at millisecond level because the data rate would be too high. So these are the, ablation altitudes of meteor echoes observed by the Arecibo radar. Okay, so as you can see, most of the meteors that they burn around 100 kilometers. Okay, that is because. Sorry.
No, it's okay. I mute the collaborator.
So,
okay.
So most of the meteor echoes, they ablate at 100 kilometers, and the dominant majority of them are observed from 80 kilometers to 120 kilometers. Of course, these are the head echo statistics. If you look at the trail echoes, the echo tends to be somewhat lower. Yeah. And this is the time distribution of meteor echoes observed. So we just need to focus on the top curve, the purple curve. So this is a time in local time or solar local time in hours, and the vertical axis is the meteor rate. So what this says, around 6 o'clock in the morning, for example, and we observe about 50 meteors per minute. So that's about 1 meteor per second. So that, you can see this, there are a lot of meteors. Yeah. So if you look at, we know how many meteors that we observe, and we know the beam size. The beam size is actually very small. Is at 100 kilometers, the beam size is about 300 meters. That's about the same as the diameter of the radar. So if you take the flux rate, and then compare it with spacecraft observation, and then just ratio it, and then the typical mass that we observe at Arecibo for the meteoroid is about 10 to negative 13 kilogram. So that is well actually below the typical micrometeoroid range. I'm going to move on to velocity observations. Arecibo, as I mentioned, is located at 18 degree north latitude. So this is the equator, and this is the latitude of Arecibo. And for meteors, of course, we can do the physics because even though meteoroid or micrometeoroid, they are small, but nevertheless, all the Newton's laws or Kepler's law, that apply to planets, they apply to meteoroids as well. So meteoroids basically are a mini planet. So if you look at the physics, and then the geocentric velocity of meteoroids is going to be confined from 11 to 72 kilometers per second for intra-solar system particles. So for the Arecibo radar is pointing vertically practically all the time. So these are the color plot here shows the expected velocity, line of sight velocity that we observe at a different time. For example, if you look at the front, and then the color here, the top color, I don't know if you can see it, is about 60 kilometers per second. Okay, so for this color, the yellow color is 60 kilometers, the blue color is a few kilometers per second. This is not the vector velocity. These are the line of sight velocity. That is what we can observe. Yeah. So, and this simulation is for meteors from the apex direction. That is the direction that is directly in the motion or in the Earth's direction for motion. So these are the velocities that we have observed. Again, the horizontal axis is solid local time, and the vertical axis here represent a velocity. The bright spot means that there are more meteors observed. For example, if we look at 6 o'clock in the morning, and then there's a strong band that shows the meteor velocity is about, the line of sight velocity is about 50 kilometers per second. So this is the observation from a June period. This is from June 29. So what is to take away is here, and then the meteors tend to fall into a band. If you look at this original data, and then you see this arch. Okay. The majority of the meteors are observed from midnight to dawn time. Okay, so this is the observation from June, and then this is a similar plot, but is for a December period of time. This is from December 2011. So this plot is actually very similar to the previous one, but there's a significant difference, and that is shown here. So there's a significant difference. If of course, this plot has a lot of other information, but it's easier actually to see the inlet, because that's the shorter plot. That is the original data without the destruction of theoretical simulations. So a significant difference is that if you look at the arc, there's a thin lag. Here is from dawn to noon, and where this one, did I get the? Yeah, okay. So you look at this one, and the thin lag is in the front from noon, from midnight to dawn. Yeah. So basically, the arch, the direction is reversed. Why this is so? And this is because of the geometry. So if you look at this top geometry, and that is for the June period. When for the June period, because the Earth's rotational axis tilts toward the sun. So that what that means at noon time, your radar is pointing almost directly toward the sun. Yeah. And well, in the December period, during the winter equinox, the radar is pointing direction is shown in this red arrow. Okay, so it's pointing away from the sun, so the pointing angle is actually is quite big with respect to the ecliptical plane. So what this means that, okay, if the meteoroid orbit is perpendicular to the axis formed by the by the Earth and the sun, and then you observe the velocity is very low, because remember what we observe is not just the vector velocity, is not the vector velocity, it's just a line of sight velocity. Okay, the velocity that is in the direction of the radar. So the difference from the June observation and the December observation is the pointing direction. Well, so here in the June observation, because the pointing direction is perpendicular to the sun, if the orbit is, if this is the normal direction of the orbit, and then you observe very little line of sight velocity, because all the trajectory of the meteoroid, they are perpendicular to our radar. So this is what is happening. So the conclusion here is this difference is because of meteoroid orbit. So the majority of the meteoroid, they are actually on the circular orbit or quasi-circular orbit at different inclination. And we also did some study of, what is the radiant direction of the of those meteoroids. So this is in the Earth's reference frame, and this is central point, the apex direction or anti-apex direction that is directly opposite to the Earth's motion. And this is anti-helium, helium that's toward the sun. This is toward the sun, is away from the sun. And we also transform that into the solar reference frame. And if you look at where those meteoroids actually are coming from in the solar system, without regard to where we are, that is in the solar reference frame, and this is sort of the direction where those meteors are. So what this shows, actually, there are more meteors coming toward us than meteors sort of catching the Earth. Okay, and of course, each instrument has its own bias. Okay, because we observe the radar pick up echo when there's a lot of ionization. When the meteoroid velocity is high, and then you got more meteors observed. So that gives us some bias. But if we look at sort of and take that into consideration, or correct for that, for the instrument bias. So this is the direction of where those meteors are coming from and how many. So what this says actually in the anti-apex direction, that is the direct opposite to the Earth's motion. Those are the the meteoroid that in retrograde orbit, and there are actually fewer meteors than those meteors catching up the Earth from the back of the Earth. The meteoroids that you observe, a lot of those meteoroids, of course, meteoroids, they ablate. Only those a small number will survive. So if you ask the question, the meteoroids that you pick up, which direction that they come from, probably the dominant meteoroids, they are coming in the direction in the prograde direction. The reason is that because the prograde meteoroids, they tend to have a smaller meteors. Okay, when the velocity is small, and then it has a much better chance to not to be burned up during its entry into the atmosphere. So this is the velocity that we see. Okay, so one is corrected for the collisional probability, another is not. So predominantly, that's the heliocentric velocity is about 30 kilometers per second, and of course that is the characteristic of particles or planets moving around the sun at 1 AU. Okay? So that is the orbital velocity of the Earth. I probably run out of time. Do I still have 1 minute to finish this, or I can jump into the conclusion?
Oh, you have some time if you want to finish.
Okay, all right.
It's very interesting.
All right, okay, so the meteoroids that we observe are on quasi-circular orbit. So why that is so? Okay, so we want to answer that question. Those micrometeoroids orbits, they are significantly affected by radiation pressure. So when the planets, of course, the radiation pressure is is there all the time. But if you have a planet or even a particle that is 1 kilogram big, and the radiation pressure is totally negligible. Okay, so how do we estimate? Well, when does the radiation pressure comes into play? And that is determined by the ratio of the radiation pressure to the gravitational force. So that is, that ratio is called beta. When beta is larger than 0.5, the particle will be blown out of the solar system. The larger the beta is, and then the smaller the particle is. So when beta 0.5 is a critical sort of value. If beta is larger than 0.5, so the particle, they will be going to be pushed out by the solar radiation as well as solar wind drag. They are going to be blown out of the solar system. So for 0.5, the particle size is about 1 micrometer, and they typically have a mass of 10 to negative 14 kilogram. So when beta is smaller than 0.5, a particle will spiral toward the sun. So their orbit is going to be, in this case, the radiation pressure of the solar wind drag is to cause a loss in angular momentum. When the angular momentum of the meteoroid becomes reduced, and then their orbit is they're gonna spin to spiral. The meteoroids are gonna spiral toward the sun. That means that they're gonna get closer and closer to the sun. But meanwhile, and then the circular become more circular. originally, their orbit can be a very elliptical. And then, but during this evolution from the outer solar system to the inner solar system, when it comes to 1 AU, and then their orbit becomes more circular than compared to when they are like a 5 AU or 10 AU. Yeah. So the meteoroid mass that we observe, they are typically around 10 to the negative 11 to 10 to the negative 13. So those meteoroids that we observe at Arecibo, they are going to be subjected by the solar radiation pressure, that is a Poynting-Robertson drag force, as well as the solar wind drag. So because of the meteoroid mass, okay, so you can imagine that when those meteoroids, they were originally generated, for example, in the asteroid belt, even though their orbits may be highly elliptical, but when they evolve, when they collide with the Earth at a distance of 1 AU, and because they have evolved in millions of years, so the orbit becomes more and more circular. So that's why the meteoroids that we observe, they are, for the most part, they are on close to circular orbit. So here's my conclusion. The Arecibo meteoroids with a mass around 10 to the negative 13th, they are the smallest dust particles observed by any ground-based instruments. So this size is actually very close to the dust particle mass observed by spacecraft. And most of the particles are observed on quasi-circular orbits. And the reason for that is because Poynting-Robertson and solar wind drags play a very important role on the evolution of the meteoroid orbits. So there are some other sort of conclusions that I didn't touch upon. For example, so some people reported a lot of interstellar dust particles. Well, the lines that I was showing on the velocity plot, shows what is the likelihood that a meteoroid may be from interstellar origin, out of a solar system. But Arecibo observation does not show obviously there are many interstellar dust particles. All right, thank you very much for your attention. Be more than happy to entertain any questions.
Okay, thank you. Very, very nice and very interesting presentation. I would like to ask two things. One is about the statistics. You mentioned that you detect 1 meteor per second.
Right.
And that is a lot. And
it's a lot.
Yes. And the second question is, all these are detected by radar, but how many are detected visually? It means in the visible region.
If the meteors that we are seeing, they are so small. Okay.
Yeah.
Those meteors, even if you observe, probably, most of the meteors burns at about 100 kilometers.
Yeah.
If you look at the range, we see those meteor trails, they are probably about 200 kilometers away. But even if you sit next to it, you may not necessarily see them.
Okay.
So,
okay. Very, very interesting, because I believe that the statistics was less, but it's incredible.
Yeah, these are the most, these are the most powerful radars in the world. And then, yes, it's not only that we observe so many meteors, per minute, and then also actually the beam size is very, very small. When we look at meteors, we see half of the sky.
Yeah.
But we are seeing for the radar sees, only 300 meters in diameter at 100 kilometers. So it's like it has a very, very narrow field of view.
Yes. And finally, I never hear about the Arecibo power to detect this kind of phenomena. The collapse of the antenna is a real loss for this kind of studies.
Yes, it is a big loss. Yes.
Yeah.
There's no doubt about it. Yes, it was a sad moment, and the antenna, collapsed on December 1st, 2020. So
Yeah.
it was, it was a kind of a devastating to the community. Of course, my background is in atmospheric and space science, and of course, Arecibo was actually mainly used for radio astronomy and planetary astronomy. What I'm talking about here are the meteoroids, and then it's of scientific interest, and then some of them may drop to the ground, and then excite interest in a lot of high school students or elementary school students. But Arecibo actually it was used actually to trace asteroids. Because Arecibo is so powerful, and even when asteroids are very, very far away from us, and we can sort of trace them and look at the orbit and to see if there's any chance that it may collide with the Earth. So.
Well, thank you very much, because it was an amazing presentation.
Thank you for the invitation.
Rosa?
Thank you very much. I would like to say to him and to the rest of the authors and the speakers that we would like to collect the PowerPoints and to put in the website also with the YouTube record of this session. But we believe that also is practical, that there are many information, many details that they are very important for all of us. Then I would like to invite him to email to Beatriz or to me or both the PowerPoint, and the same for the rest of participants.
Yes, it's a very good idea. There are some people asking for the record of the meeting. The meeting is been recording in YouTube channel and will be there forever, I hope. And but the presentations, the PowerPoint presentations are very, very useful also. So I invite the people to send us all the PPTs.
Maybe we can introduce the next speaker. The last one speaker is Antoni Selva. He is member of Associació Astronòmica de Sabadell. This is an association of amateur association, Spanish Amateur Association, but they are very, very professional. They work with astronomers, professional astronomers for many years, and they have a group of occultations. And Antoni is member of this team. And well, I would like to mention that after his talk, we maybe to some details more, that there is one special situation that Jake Pasakov, member of NASE, that died 1 year ago, then he suggests to us that we organize an activity. And then I think it is a good idea that in 5 minutes, he said to us the proposal, the future proposal about this, that of course all of you are invited to participate. It is a very, very special opportunity to observe one occultation that it could be very spectacular, but maybe it's impossible that we don't see anything. Please, Antoni, the title of the presentation is "Will we see the constellation of Orion without the star Betelgeuse on December 12th? This is the question. Antoni.
Okay. Good afternoon. Thank you for your kind presentation. I try to share the presentation. Okay. Do you see it?
Yes, very good.
Okay. On December 12th, we will have the occultation of the star Betelgeuse by the asteroid 319 Leona. Betelgeuse is a very bright star, so that's an once in your life phenomenon. The result of the observation is uncertain, as you will see. Wait a moment. Okay. In an usual asteroid occultation, the asteroid covers completely the light of the star, because the apparent size of the asteroid is much larger than the star. The asteroid projects on the Earth a shadow with its same size and shape of the asteroid. Observers inside the path observe the full occultation, but others outside not. Okay, Leona is a small body from the main belt asteroid located between the orbits of Mars and Jupiter, and orbits like the planets of our solar system. Betelgeuse is the main star of the well-known constellation of Orion. You can see here Betelgeuse is the 10th brightest star in the night sky, and you can see here the difference of size. Betelgeuse is about 900 million kilometers. Leona, it's only 70 kilometers. Despite the great difference in size of both objects, the apparent size are very similar. So we will have an event very similar to a solar eclipse. In a solar eclipse, in the shadow projected in the Earth, we have areas with a partial occultation of the sun, and others in the center, we have a total occultation of the sun. Depending if the moon covers all the surface of the sun, you will have a full eclipse solar or annular eclipse. Here we have the map, the predicted shadow of the Betelgeuse occultation. The shadow will travel from east to west. As example, I mark 3 possible locations. That people can see this event. These are the times in universal time, of course, and the east part of the path will occur at the end of the night, near the beginning of the day, in the middle at midnight, and in the west part, for example, in Florida, it will occur at the beginning of the night of the previous day in local time. Here we have the detail of this path. The purple lines indicates the area where it's supposed to be a full occultation of Betelgeuse or annular, we don't know. And the blue lines limit the areas of partial occultation. The red lines are the uncertainty. I remind you that this is a prediction, and the shadow can be shifted to the north or the south, as indicated the uncertainty. Okay. The overall duration will last about 12 seconds in the center line. Here we have a model that will occur depending in the area you will observe. This part is the north limit, the northern limit. Here is in the northern part, in the middle of the northern part, the central part, the middle of the southern part, and the southern limit. But you don't will see the shapes and the quotation in this way. You only can see the dimming of the light of the star. So the star is punctual, you only see the dimming. Bigger area are occulted of the star, more drop you will see, more dimming you will see of the light of the star. Okay, in conclusion, we don't have certainty of the result of the observation. We don't know it will be a full occultation or not. The main uncertainties come from the position and size of Betelgeuse. It's a star so large and bright to have a good astrometry. If the apparent size of Leona occurs completely Betelgeuse, one could detect a full occultation if the observer is in the correct place, and this will help to determine a better position of little shields. Nevertheless, if it's not possible to observe a full occultation, the results will be good enough to improve the position of the star. That's all. Thank you. Do you have any questions?
Okay.
I've been very fast.
No, very nice. No, very good, very good. Just a question, a practical one. Do you transmit the observation? Because in America, that time is between, well, in South America, between 7 and 10 p.m. So it's a good moment to be attentive about the observation.
Yeah. Well, in America, the only place.
No, we cannot see. No, we cannot see. But my question is, if you are planning to transmit, to make a streaming or something like that for the rest of the world.
Something is proposing that from Europe, Diota. I don't know for certain.
Okay. I would like to say that we, NASE, we propose, and they are agreeing, that to offer you this image on Saturday 16, December 16, in order to show what they are obtained, because they have to go to the south of Spain. Sabadell is very close to Barcelona. Then it's not possible to observe. And they are planning to go to the south of Spain. Maybe, Maria Pilar, you have possibilities to observe, not in Argentina, but you can, some kilometers from.
Exactly, where I come from, the quotation would be fully where my hometown where I was born. So I definitely will be there. Definitely will be there.
Our plan is to organize one event like this, 1 hour, 2 hours even. Then with their contribution, of course, this is the crucial and the central idea. After you can see the proposal of Jay Pasakov was that it will be possible to observe in Spain, in Italy, and in Greece. Then I suggest that maybe one group of students in Spain, and my idea was to talk with you, could give us, because this is on Tuesday, not Tuesday, on Saturday, that these students can explain to us, take some photos, some materials, and explain to us their feeling. The same in Greece, because I talked with Margarita Metaxa in Greece, and she's interested to do, she's planning to do something. We have preliminary contacts in Italy, and I think it could be a good idea to explain all of this, because we don't know exactly it will be very visible or not. I was talking with Antoni and with Carlos Navarro, is also another member of the group, and they really don't know exactly what was the observation at the end, because there are many things to take into account. The star is very big, the asteroid is very small, and of course the distance is very important, and all of this. And we plan this activity also. We would like to recognize the excellent work by Jay Pasakov, and in some way to have a memory for him. I would like to talk in this moment about Paolo Bretonischi, was another member of NASE that died last year also. And there are crucial people for us that we believe that it's important to mention these people, no? And also we want to invite to the wife of Jay, Naomi, and probably one of her sisters could introduce some lines about the activity of Jay Pasakov, because he was really a very important man. And probably some of you have at home one guy, the observation of the sky written by him, because it is in all our houses for amateurs or for professional astronomers, not in all the houses of the world. But he was a very important person. And then we plan to organize more or less, we are talking about this. I know it is very close, but we invest our energies, Beatrice and myself, to prepare this event. Then it was not possible to work in both. Okay, we need to work, but our idea is more or less like this. No? Beatrice, do you want to mention something more, some aspects? I don't know.
No, you cover everything. As you mentioned, Paulo Bretones and Jay Pasakov were very, very good friends and also part of NASE program. So it's good to remember them, but also to continue the legacy. So this is the idea, to continue with the legacy from these guys, very important guys, ex-presidents of the Commission 1 in the Astronomical Union, International Astronomical Union. Both were presidents of the Commission of Education and Development of Astronomy. So this project is a particular project of Jay Pasakov, and well, the idea is to make what he cannot. So, we invite you, and if you can go to the totality, would be great, because I believe will be an experience. Even if you cannot see everything or the phenomena, would be. Astronomy is always an experience and is always a groupal activity, an activity where the people is happy to be and to participate. So please try to join us and to invite more people in your countries and your local places.
Yes, and don't forget that next year we plan a new one, NASE UNESCO project for the International Day of Light. And I was very happy, Beatrice, because yesterday, one of the persons that are here asked me about the next project. If we have ideas. It was especially Ambrose. Ambrose said to me, what is the idea that you have for next year? Well, then, sorry, but you and me have to think something. Okay. But we promise that we will do it. But at first, this memory to Jay Pasakov, okay? Thank you very much for all of you. I would like that you finish, and this is enough.
Yes, thank you, everyone, and close. Goodbye, and have a very nice day and weekend. See you soon. Bye-bye.
Bye.
Bye. Have a good time.
Beatriz in Argentina. Well,
bye-bye.
I have here a collection of certificates for all of you. Yeah. I want to give